In a distant corner of the universe, more than 390 million light-years away from Earth, a wound was torn into the fabric of space so wide, so violent, and so unfathomably deep that even the ancient silence of the cosmos seemed to tremble in its presence. There, hidden within the Ophiuchus galaxy cluster, astronomers uncovered evidence of something beyond extraordinary, a cosmic event that shattered records, broke expectations, and hinted at forces that operate on scales our minds were never meant to grasp. It was not merely an explosion. It was not a supernova, not a collision of stars, not even the death of a galaxy. It was something greater, something older. It was the most powerful outburst ever observed in the known universe. Before we begin, tell us in the comments where in the world you're watching from and what time it is there. And if you can, like the video and subscribe. It helps us keep exploring the unknown together. At the heart of this titanic eruption lies a black holy behemoth of such vast proportions that the mind instinctively recoils from the numbers. Scientists estimate its mass to be in the billions of suns, a gravitational force so absolute that not even light, the swiftest thing in existence, can escape its grip. Yet what truly stunned researchers was not the black hole's presence, but its ferocity. Using data from NASA's Chandra X-ray Observatory, as well as radio telescopes scattered across Earth, astronomers discovered an enormous cavity in the surrounding Gaza void, so massive it could fit 15 Milky Way galaxies inside. This cavity was not empty by chance. It had been carved, slowly and violently, by jets of energy erupting from the central black hole, moving not in moments but over hundreds of millions of years. Dr. Simona Giacintucci, who led the study, described it as a remarkable discovery that was like the eruption at Mount St. Helens, except you could fit 15 Milky Way galaxies in the crater. And just like that terrestrial volcano reshaped landscapes on Earth, this cosmic blast sculpted its environment in ways that echo across the void, long after the first shock waves faded. But how does a black hole, an object defined by its hunger, unleash such creation through destruction? To understand this paradox, we must travel inward, not outward into the mechanisms that power active galactic nuclei. At the center of many galaxies, these supermassive black holes do not merely consume matter. As gas and dust spiral into the event horizon, the swirling mass becomes superheated, generating colossal magnetic fields and forces so intense they reverse direction. Instead of falling inward, some matter is ejected outward along the black hole's poles at nearly the speed of light, forming jets that pierce the galactic halo and beyond. Over time, these jets can transfer unimaginable amounts of energy into the surrounding space, heating gas, shaping star formation, and in the most extreme cases, excavating chasms in the cosmic medium itself. In the case of the Ophiuchus black hole, the energy required to create the observed cavity was estimated at 5 times greater than the previous record holder. To release such energy is to surpass the total output of billions of suns over hundreds of millions of years. And yet, this did not occur in a single instant. The black hole, it seems, had been quietly shaping its domain for eons, an ancient artist painting with radiation and gravitational fire. Some scientists began to wonder whether this was a unique event or a glimpse into a hidden pattern. Could the early universe have been punctuated by such outbursts more frequently than we imagine? Could the large-scale structure of the cosmosets, filaments, and voids, its clusters and superclusters be sculpted not just by gravity, but by the invisible breath of ancient black holes, exhaling energy across the eons? The implications reach beyond astronomy. In this single event, we see a microcosm of the universe's strange balance, entropy and order, destruction and rebirth, chaos and harmony. The black hole, once considered the ultimate symbol of annihilation, now emerges as a paradoxical force of cosmic renewal. It is not only what it devours that defines it, but what it gives back in the act of taking. Like fire clearing a forest to make room for new growth, the black hole's fury may sow the seeds of future galaxies. Perhaps we are just one chapter in a much older story. Perhaps our universe remembers these colossal moments not as exceptions, but as rhythms in its eternal song. The silence we hear in the night sky is not emptiness, but aftermath stillness that follows a scream so vast it echoes across time. If all this is true, what else lies hidden in the shadows of the cosmos, waiting to awaken once more? The deeper we look into the heart of cosmic violence, the more we are forced to reimagine what power truly means. Power in human terms is often loud, immediate, and final. But in the universe, power can be slow, quiet, and impossibly vast. It can unfold over hundreds of millions of years, and yet leave behind scars that will remain long after every star in the sky has burned out. In the story of the Ophiuchus outburst, we are not witnessing an explosion like a firecracker in the night. We are witnessing something akin to the slow tearing of space itself, a cosmic storm whose winds blow not for days or years, but for epochs. This outburst, the most energetic ever recorded, radiated the equivalent of 1054 joules of energy. For comparison, this is hundreds of thousands of times greater than any gamma-ray burst or quasar flare ever detected. The numbers, while technically impressive, become almost meaningless at this scale. They transcend comprehension, becoming symbols of a reality where human frames of reference collapse under the weight of magnitude. And yet, the universe absorbs this violence like the ocean absorbs a drop of ink with subtle ripples that travel outward, marking time in ways our instruments are only beginning to perceive. The cavity left in the intergalactic medium is a relic of this passage. It is shaped not only by the explosion, but by the medium itself, the hot, diffuse plasma that fills the space between galaxies. This plasma, often overlooked in favor of the galaxies it surrounds, acts as the canvas upon which black holes draw. When jets of relativistic particles carve through it, they displace the gas, heat it, and even trigger new chains of events that may lead to the birth of stars or the collapse of cosmic filaments. In this way, a black hole's rage becomes a sculptor of the invisible. To grasp the scale of this phenomenon, imagine a void the size of 15 Milky Ways, hollowed out and shaped by jets that extended for hundreds of thousands of light years. These jets, although composed of particles moving near the speed of light, are not beams of fire like mythic weapons. They are streams of invisible fury, magnetically confined and driven by the rotational energy of the black hole itself. This process, known as the Blandford-Znajek mechanism, is one of the leading theories explaining how spinning black holes power such jets. It proposes that magnetic fields threading the event horizon extract rotational energy, channeling it outward in the form of colossal, focused outflows. In this model, the black hole becomes a kind of cosmic dynamo engine, so efficient it could run for 1 billion years without losing momentum. What we see, then, is not an isolated eruption, but a dialogue between the black hole and its environment. The outburst is shaped by the gas that surrounds it, and in turn reshapes that gas. This feedback loop, once thought to be relatively minor, is now understood to be essential in regulating the growth of galaxies and the evolution of clusters. Without it, galaxies might grow too large, their stars too quickly formed, exhausting the fuel of creation prematurely. With it, a delicate balance emerges, a kind of cosmic thermostat maintained by the very engines of chaos. And yet, the deeper this discovery reaches into astrophysics, the more it whispers to ancient fears and questions. If something can release this much energy without our awareness, operating in silence across billions of years, what else might be lurking in the darkness? What other monsters sleep beneath the veil of observable light, their hearts beating in wavelengths we have not yet learned to hear? Some theorists have begun to speculate that such outbursts might not be rare anomalies, but signposts of a deeper, more pervasive process. In models of dark matter and cosmic structure formation, the role of black hole feedback is growing ever more central. These violent events could help explain not just the shape of galaxies, but the very web-like skeleton of the universe itself. By injecting heat and turbulence into the intergalactic medium, black holes may slow down the collapse of matter, allowing the cosmic web to form with the delicate intricacy we now observe. In this light, black holes are not only destroyers, but regulators. They are the guardians of balance in a universe prone to excess. Their violence is not mindless, but functional. In the dance of matter and void, they play the role of conductor not with a baton, but with jets of relativistic plasma. What does it mean to live in such a universe? A universe where the greatest energies ever released come not from war or will, but from natural processes that play out without audience or intention. It suggests a cosmos in which meaning is not assigned, but discovered, a place where the sublime hides not in comfort, but in the terrifying beauty of scale. We often look at the night sky and imagine peace. But peace is a local illusion. The calm of our solar system is not typical, but rarely a fleeting pocket of stillness in a sea of movement. Just beyond our view, the cosmos is alive with radiation, collision, and eruption. The Ophiuchus outburst is only one such heartbeat, and yet it calls us to listen differently. Not for signals from civilizations, but for the whispers of phenomena far beyond intelligence, the songs of structure itself. And so, we are left with a paradox. In studying the greatest explosion ever recorded, we do not find chaos, but orchestration. Not the end of something, but the beginning of a deeper understanding. This event, this silent roar from a galaxy cluster billions of light years away, is not just data. It is a message written in energy. A message that says, the universe is more dynamic, more balanced, and more interconnected than we have dared to believe. If a single black hole can shape galaxies, what role might they play in shaping the destiny of the cosmos itself? Could they be the regulators of time, the keepers of cosmic memory? Could they, in some unfathomable way, be the architects of the very conditions that allowed for life to emerge here, on this fragile blue world spinning in the dark? Perhaps, in the distant echoes of the Ophiuchus outburst, we are not just hearing the past. Perhaps we are hearing the foundation of a story still being written, a story that includes us, but is not about us. A story of gravity and light, of silence and eruption, of deathless engines spinning at the centers of galaxies. And if all of this is true, then what we call monsters may be something else entirely. Not threats, but forces of balance. Not destroyers, but curators of the cosmos. The sky, it seems, does not just shine, it remembers. Long before the Ophiuchus explosion rippled through the galactic ether, long before galaxies had even coalesced into the luminous spirals and clusters we now see scattered across the night sky, there was only darkness, a formless, opaque void wrapped in silence. In this primal darkness, the first black holes were born, not from dying stars, but perhaps from the very energy of creation itself. Known as primordial black holes, these hypothetical entities are believed by some to have formed in the first fractions of a second after the Big Bang, forged in pockets of extreme density where matter collapsed under its own weight before atoms even had time to form. Their existence remains unconfirmed, but their implications are vast. If they exist, these ancient shadows could be the seeds from which galaxies grew. Some might still roam the universe today, quiet and invisible, their presence betrayed only by the subtle gravitational echoes they leave in the motion of stars and the bending of light. Could one of them have survived for over 13 billion years, growing in silence, feeding slowly from the ambient darkness, until one day it unleashed a fury like the Ophiuchus outburst? We cannot say for certain, but what we do know is that black holes are not merely endpoints. They are, paradoxically, also beginnings. They shape galaxies, regulate the birth of stars, and perhaps even preserve the memory of earlier universes. The very fact that we can detect the cavity in the Ophiuchus cluster, this hollowed-out scar of unimaginable violence, is a reminder that space remembers what it endures. And yet, what we see is only the surface of a much deeper mystery. Modern cosmology is beginning to glimpse something stranger than fiction, the idea that black holes might hold within them not just crushed matter, but entirely new regions of space-time. Some solutions to Einstein's equations suggest that the center of a black hole could become a passage not into oblivion, but into another universe. These ideas, though highly speculative, are rooted in real mathematics. They are known as white holes, the theoretical mirror image of black holes, where nothing can enter and everything is expelled. No evidence has yet confirmed their existence, but their possibility lingers at the edge of science like a myth waiting to be remembered. In this light, the Ophiuchus event takes on a new dimension. What if the eruption we witnessed was not merely energy escaping into space, but a communication from a deeper structure of reality? What if these colossal jets are not just byproducts of physics, but indicators of something emergent, a signal, not from intelligence, but from the very architecture of the multiverse? Dr. Laura Mersini-Houghton, a physicist known for her bold ideas on cosmology, has proposed that our universe could be just one among many a bubble in a frothing sea of universes, each born with different properties, some perhaps ruled by black holes that operate under entirely different laws. If true, then the monsters we fear might be gatekeepers rather than destroyers, standing watch at the boundaries of reality itself. And what of time? Inside a black hole, time as we understand it ceases to exist. To an outside observer, anything falling in appears to freeze at the edge, stretched infinitely as it approaches the event horizon. But to the falling object, time flows normally, even as it approaches the singularity, that mathematical point of infinite density where our understanding collapses. In the presence of such extremes, perhaps time folds in on itself. Perhaps the past and the future are not as separate as we think, and the Ophiuchus explosion is not just an event in our history, but a fixed point in a loop, reverberating across epochs. There is a growing idea among theoretical physicists that black holes may not destroy information, as once feared, but preserve it in their outer boundaries, encoded like ancient runes in the quantum fluctuations of the event horizon. This is the essence of the holographic principle, the notion that the contents of a volume of space can be described by information on its surface. If true, then black holes become more than cosmic beasts. They become libraries. Archives of all that has fallen within them, etched into the fabric of space like memory etched in the mind. So when we look at the Ophiuchus cluster, we are not just seeing an explosion, we are seeing an opening, a tear through which information flowed, was transformed, and perhaps even shared, a great act of release, not random, but ordered, like a symphony playing in a key we have not yet learned to hear. The more we study these cosmic monsters, the more they seem to challenge the idea of finality. They are places where known laws break down, and yet, from that breakdown, something coherent and structured still emerges. In them, we find echoes of the Big Bang, suggestions of other universes, and perhaps, in their silence, the questions that will guide us for centuries to come. To stand beneath the stars and think of the Ophiuchus outburst is to feel small, yes, but not insignificant. It is to sense that we live in a universe that is still creating, still erupting, still evolving. A universe in which even destruction may be a form of communication, and in which every void is not just emptiness, but memory. What else, then, lies buried in the cosmic ruins? What other signals have we missed, mistaking them for noise? What ancient engines are still spinning in the darkness, waiting for their turn to speak? The answer, perhaps, is not in what we see, but in how we listen. The universe, after all, does not shout. It whispers. And it waits for us to learn its language. There are places in the cosmos so far removed from light, from heat, from time as we know it, that even the most sensitive instruments ever built by human hands can barely whisper their presence. These are the void cements regions between galactic clusters where matter thins almost to absence, and the silence is so profound it becomes a kind of presence itself. And yet, within this silence, there is motion. Within this darkness, there is memory. Cosmic voids, despite their name, are not truly empty. They are threaded with tenuous gas, dim dwarf galaxies, and the faint echoes of ancient gravitational tides. Some scientists now believe that the largest black holes monsters, like the one in the Ophiuchus cluster, may have played a crucial role in shaping these voids. Through outbursts that ripple across hundreds of millions of light years, these black holes could have cleared vast paths through the cosmic web, sculpting the structure of the universe on scales so immense we can only trace them in patterns of shadow. Imagine the aftermath of a single black hole outburst, jets of plasma, stretching far beyond their host galaxy, plowing through the intergalactic medium like cosmic wind through tall grass. The heat alone would be enough to halt the cooling of gas for millions of years, preventing star formation in entire regions. The density would drop not because matter disappeared, but because it was pushed aside, displaced by waves of force. In this way, black holes may have helped carve the great voids we now see as gaps in the cosmic map. And these voids are not inert. They move, they breathe, they even carry with them a record of the ancient universe. Cosmologists study the motion of galaxies near the edges of voids and find that these galaxies flow like water down a slope, pulled by the uneven distribution of mass in the cosmos. It is as if the universe itself is still adjusting, still echoing with the weight of primordial upheavals. The Ophiuchus outburst, then, might be more than an isolated event. It could be a memory of the processes that shaped the very scaffolding of the observable universe. A fingerprint of a mechanism so immense and ancient that its logic transcends galaxies, connecting clusters through invisible lines of influence and disruption. There is also the strange phenomenon of alignments. Across vast distances, some quasars and galactic jets appear to be oriented in similar directions, as if responding to a deeper order in space. The reasons remain speculative. Perhaps magnetic fields on intergalactic scales, or relics of conditions from the early universe, guide these alignments. But some researchers wonder, could ancient black hole outbursts, like Ophiuchus, have synchronized distant regions through their titanic release of energy, nudging the geometry of space in ways that subtly persisted? It is a humbling notion that a single explosion, unfolding over eons, could shape the spin of galaxies millions of light years apart. But this is the scale we must now consider. The universe does not build in centuries. It builds in cycles of emergence and collapse, in waves of influence that take billions of years to ripple outward. And what if these ripples don't just move through space, but through something deeper, through the fabric of space-time itself, or even through dimensions we cannot yet measure? Theoretical physics opens the door to such possibilities, with models that suggest our universe may be embedded in a higher dimensional reality. In such a framework, black holes may be not only singularities, but portals, nodes where dimensions intersect, where energy and structure can bleed across boundaries we have yet to define. This raises a question both unsettling and sublime. When a black hole like the one in Ophiuchus erupts, where exactly is the energy going? We see the jets, we see the heat, we map the voids. But is that all? Or is there a portion of the event that slips away, leaving our reality through channels we are not equipped to follow? Some physicists, like Juan Maldacena, have suggested that the interior of black holes could be described by duality's mathematical mirrors that link gravity and quantum theory. In these ideas, space-time is not fixed, but emergent. The very geometry of the cosmos arises from information, from entanglement, from computation. If this is true, then black holes are more than astrophysical objects. They are engines of transformation, not only within their own surroundings, but within the nature of reality itself. The energy of the Ophiuchus event, then, might be more than heat and motion. It might be a kind of updatea message, not in words or light, but in the fundamental code of space, a recalibration of geometry, a redefinition of boundary. As we uncover more of these events, more cavities in the intergalactic medium, more echoes of ancient violence, we may begin to read a hidden history of the cosmos, a story not written in stars, but in absence. A tale told not by what shines, but by what was displaced. And still, the question lingers. What woke the monster in Ophiuchus? Was it simply the slow accretion of matter, the random infall of gas pulled by gravity? Or was there a Trigura merger with another black hole, a tidal interaction, a shift in dark matter density? The truth may never be fully known, but the question itself reveals the depth of our curiosity. In asking it, we acknowledge the complexity of a universe that thinks in patterns far beyond our scale, that balances creation and destruction not as opposites, but as phases of a deeper rhythm. So the voids are not empty, they are resonant. They are shaped by ancient outbursts, by forgotten violence, by the restless hunger of black holes that do not sleep. And in their silence they speak. They remind us that the cosmos is not built only of matter, but of memory. Not just of galaxies, but of gaps. Not just of stars, but of shadows. In the end, perhaps it is not what the black holes destroy that defines them, but what they leave behind. A silence so deep, it sings. In the cold archives of space, light moves like a messenger from ancient times. Every photon that strikes our telescopes has traveled a journey of unimaginable duration, carrying with it the stories of distant stars, of collisions and births, of silence and sudden flare. But not all stories arrive in light. Some come in waves, faint ripples in the fabric of space-time itself, whispered tremors from the most violent corners of the universe. These are gravitational waves, the breath of black holes. When LIGO first detected gravitational waves in 2015, it opened a new window into the cosmos, a way to hear the universe rather than just see it. The signal came from two black holes spiraling into each other, merging into a single, more massive entity in a final moment of furious unity. The energy released in that collision, in just a fraction of a second, was more than the power emitted by all the stars in the observable universe combined. And yet, by the time it reached Earth, it was no more than a trembling in the detectors, a change in length smaller than a proton. What might we hear, then, if we listened to the black hole in Ophiuchus? Could its outburst, slow and massive though it was, have also created waves? Could the formation of the enormous cavity, the gradual but relentless displacement of matter, have caused space-time itself to ripple ever so slightly, telling its tale in vibrations too deep for our current instruments to perceive? Unlike mergers, which produce sharp bursts of gravitational waves, slow outbursts like Ophiuchus may generate a different kind of echoa low-frequency murmur, a bass note in the cosmic symphony that stretches across epochs. Detecting such waves would require instruments far beyond what we now possess, observatories in space that can track the flexing of spacetime across millions of kilometers. Projects like LISA, the Laser Interferometer Space Antenna, are designed for this purpose. Once operational, they may reveal the slow chorus of black holes singing in deep time. But even in the absence of detection, we can imagine the weight of such a song, a gravitational hum that reverberates through the cosmic web, pressing subtly against the filaments of dark matter, shifting the dance of galaxies in ways imperceptible to light. In such a vision, the universe becomes not only a visual spectacle, but a soundscape multidimensional tapestry where every black hole is a drum, every merger a cymbal crash, and every outburst, like Ophiuchus, a rolling thunder, heard only by those who know how to listen. Some researchers now explore the possibility of a stochastic gravitational wave background, persistent, diffuse echo from countless overlapping sources. If such a background exists, it may carry the fingerprints of ancient events, including black hole activity from billions of years ago. The Ophiuchus monster, then, might be not a soloist, but part of an ancient chorus still resonating through the bones of spacetime. And perhaps, just perhaps, these waves are not random. Perhaps they carry patterns, rhythms, even structure-hidden messages encoded not by intention, but by the fundamental mathematics of the universe. Could such vibrations be part of a universal syntax, a language of gravity that connects the cosmos across gulfs of time and distance? We do not know, but to ask is to expand the frontier of thought, to push against the boundaries of silence. In studying gravitational waves, we are not only investigating black holes and neutron stars. We are tuning our senses to the deepest frequencies of existence, to the slow breathing of creation and collapse. Consider this. If the Ophiuchus outburst did send out gravitational waves, then somewhere, drifting far from its source, those waves are still moving, still stretching and squeezing space as they travel. And perhaps one day, long after we are gone, they will reach a new world with new ears and be heard again. In this way, black holes become storytellers, not through words, not through light, but through motion itself, through the flexing of the cosmos, through waves that remember the shape of their origin. This changes our relationship with the sky. It becomes not only a map, but a score, a symphony composed by forces beyond imagining, played across the longest stage there is. And we, small as we are, become its audience, and perhaps, someday, its musicians. What else will we hear when we finally learn to listen in full? What ancient explosions are still singing? What dormant giants are still humming their songs of gravity and fire? The answer may be waiting, pulsing faintly in the background of all things. A music written in the structure of space-time itself. A hymn of the monsters. And we are only beginning to hear the first notes. In the quiet darkness beyond the veil of our perception, there are relics not just of light and motion, but of temperature itself. Across the cosmos, a faint background persists, a residual glow left over from the birth of everything. This is the cosmic microwave background, or CMB, a near-uniform sea of radiation that fills all of space, a whisper from the moment when the universe first became transparent, about 380 years after the Big Bang. It is the oldest light we can see, and it tells us the most ancient story we know. But this ancient light is not perfectly smooth. It carries within it tiny variations-minute fluctuations in temperature and density, like scars on a fossil. These anisotropies, mapped with exquisite detail by satellites like COBE, WMAP, and Planck, are the imprints of the early universe's seeds of structure. And buried within these patterns, some researchers believe, are clues not only to the formation of galaxies and stars, but to the role that black holes, even in their earliest forms, may have played. Could black holes have existed before the first stars? The idea seems paradoxical, but it is gaining traction. Some theories propose that in the first split seconds after the Big Bang, regions of extreme density could have collapsed directly into black holes, the primordial kind. These ancient entities, if they still exist, could be as small as asteroids or as massive as a star, and they may account for some or even all of the dark matter that shapes the cosmos. If black holes are part of the dark scaffolding of the universe, their influence would not come from light, but from gravity. Their presence would be felt in the way galaxies rotate, in the bending of light from distant objects, and, subtly, in the patterns of the CMB itself. Some anomalies in the microwave background, slight cold spots, unusual alignments have fueled speculation that massive, primordial black holes may have left fingerprints there long before the cosmic monsters we know today had begun to awaken. And yet, this is not only a question of astrophysics, it is a question of narrative. If black holes existed before the first light, then they are not just the end states of stars. They are not merely the ashes of burned-out suns. They are co-authors of the universe's story from the very beginning. What would it mean to live in a cosmos where black holes preceded illumination, where darkness came first and light was the interruption? It flips our intuition. We often think of the universe as a brightening, a slow ignition leading from chaos to clarity. But if the first true objects were black holes, then the story is different. It is not a journey from dark to light, but a harmony of both from the outset. Creation itself may have begun not with stars, but with gravity's most extreme and quiet expressions. These ancient black holes, if they exist, would still be here, not decayed, not vanished, but hidden. They could drift through galaxies, through interstellar dust, through the halo of our own Milky Way, silent, invisible, shaping orbits and motion without revealing themselves in light. The monsters among us, their power would be in the invisible, and that, perhaps, is their lesson. The Ophiuchus black hole revealed itself not through light, but through absence, through a cavity, a silence in the gas. In the same way, primordial black holes, if they are real, speak not through what they emit, but through what they move. They are cartographers of the unseen. This brings us back to the CMB. If we think of it as a screen, then primordial black holes might be the subtle indentations on its surface, not visible directly, but changing the way the light reflects and spreads. We might never see them outright, but their shadow would shape the image. And perhaps the same is true at larger scales. When we look at the cosmic web, the vast structure of galaxies strung like filaments across the void, we are seeing not just the pull of gravity, but the choreography of ancient influences. Black holes, both stellar and supermassive, may be the nodes in this network, anchoring the threads of matter, guiding the shape of everything. In this sense, the monsters are not invaders, not anomalies. They are the architects, the silent originators of form. Some theorists suggest that the earliest black holes may have acted as attractors, gathering matter around them, triggering the first stars, and setting the pattern for galactic formation. If true, then the luminous universe we now see, the stars, the galaxies, the nebulae, was built around the quiet gravity of things we still cannot see. The light followed the darkness, and that is a poetic reversal, because it suggests that the beauty of the sky, its color, its depth, its twinkling constellations, is not the story itself, but the consequence of something deeper. That beneath every bright point is a history, written not in photons, but in the slow pull of mass through space. That behind every light there is a shadow that came first. So we come to a strange realization. The oldest creatures in the universe may be the least visible, the most influential may be the most silent. The forces that built the stars may be the ones that shun light altogether. And if that is true, then the Ophiuchus outburst is not an exception. It is a reminder, a glimpse of an ancient pattern repeating itself, echoing through epochs. The Great Cavity is like a fingerprint, not just of one event, but of a lineage, stretching back to the birth of time. What if every galaxy, every star, every planet was shaped by a monster in the dark? What if we are not the children of starlight, but the children of shadows? The cosmic microwave background is still there, always watching. A veil that hides and reveals. A canvas painted not only by photons, but by gravity. And beneath that veil, the monsters wait. Not in rage, but in silence. And in that silence, the universe took form. From Earth, we see the universe in layers. Light from our own sun reaches us in 8 minutes, while the glow of the nearest stars takes years. Galaxies beyond our own broadcast, their ancient radiance across millions or even billions of years, turning the sky into a time machine. But beyond the reach of visible light, farther still than the longest wavelengths of radio waves, lie energies so deep and so powerful that they barely register on our instruments. Here, at the frontier of perception, black holes reign not as shadows, but as engines of transformation. Among the most mysterious features of black holes is their capacity to alter not only space and time, but the very laws that seem to govern matter. Near the event horizon, particles accelerate to near-light speeds, quantum fields fluctuate wildly, and time itself stretches until it loses all meaning. In these zones, the boundary between the classical and the quantum begins to dissolve, hinting at a deeper layer of reality that remains elusive to modern science. One theory that seeks to unite the quantum world with gravity is known as loop quantum gravity. It proposes that space itself is granular, composed not of smooth curves, but of tiny loops, like an invisible weave. According to this idea, a black hole does not collapse to a singularity, but to a finite, compressed state where quantum effects resist infinite density. Some interpretations suggest that what lies beyond this core is a bounce rebirth where matter and energy erupt into a new region of space, perhaps even forming a new universe. If true, then every black hole might be a seed, not only a destination, but an origin, a portal from one cosmic domain into another. The Ophiuchus outburst, viewed from this angle, takes on a new layer of meaning. It may not be just a relic of energy consumption or environmental shaping, but a signature of deeper processes that play the signs of a reality trying to reproduce, to bud off into something new. In this framework, universes beget universes, each born from the death throes of collapsed stars and galactic cores. This is known as cosmological natural selection, a hypothesis by physicist Lee Smolin. It suggests that universes which are good at forming black holes are more likely to produce offspring. Over time, through a kind of Darwinian evolution across the multiverse, only those cosmic environments best tuned for black hole creation thrive and propagate. Our universe, then, might be one of many particularly fertile field of gravitational collapse. This idea is not proven, and perhaps never can be, but it carries a powerful implication, that black holes are not random artifacts of destruction, but the reproductive organs of the cosmos. Their fury is creative, their silence pregnant with possibility, and yet we still understand so little. For all their power, black holes emit almost nothing directly. They do not reflect light, they do not radiate in the way stars do. We see them only by what they affect by the stars they devour, the gas they ignite, the space they distort. They are negative space made real, the outlines of something that, at its heart, might be both nothing and everything. When we detect gravitational waves from a merger, we are hearing a death and a birth. When we see a cavity like the one in Ophiuchus, we are witnessing the wake of a cosmic exhalation, perhaps the end of a cycle, or the start of one. It may be that every outburst is a kind of creation myth, written not in ancient script, but in plasma and curvature. The possibility that each black hole could give rise to a new universe invites a dizzying perspective. If true, then we may live not in the first universe, nor the only, but in one iteration of an eternal flowering, a reality where every galaxy's center holds not a tomb, but a womb. And where does that place us? We, the observers of these celestial mysteries, are built from the elements forged in the bellies of stars, organized by the laws that permit structure to form, animated by the very gravity we seek to comprehend. We are children of this universe, but perhaps also the grandchildren of black holes. If the universe is evolving through black hole formation, then we are not apart from that story. We are a continuation of it, a branch on the great cosmic tree, aware of its own growth. To contemplate this is to be humbled, not diminished, but expanded. For in the vast silence of space, meaning is not imposed, it is found. And in the language of gravity, in the shapes of galaxies, in the echoes of ancient eruptions, there is a story unfolding still. A story where monsters are mothers, where destruction is the gateway to creation, where the end of one thing is always, quietly, the beginning of another. And in the tremble of starlight, in the void between the galaxies, in the vast unknown beyond the event horizon, that story waits to be heard. By those who will dare to listen, across the dark ocean of space, there are signals we have only just begun to interpret, strange flashes of radio energy, quick as a blink, yet more powerful than entire galaxies for their brief moment of life. These are fast radio bursts, or FRBs, and they remain among the most enigmatic phenomena in modern astronomy. Discovered less than 2 decades ago, their origins are still uncertain, though hundreds have now been observed, arriving from far beyond our galaxy, each lasting mere milliseconds. What could release so much energy in so little time? The theories are many. Magnetars cracking with magnetic storms, collapsing neutron stars, exotic objects like cosmic strings, or even, as some speculate, artificial signals from advanced civilizations. But among the possibilities lies a particularly compelling one, that some FRBs may be connected to the environments around black holes. In particular, the intense gravitational and magnetic fields near supermassive black holes may act as accelerators for high-energy particles, creating conditions ripe for radio bursts. In rare cases, matter falling into a black hole might not vanish silently, but instead trigger powerful shock waves as it interacts with surrounding plasma. These shock waves could generate FRBs, making black holes not just absorbers of information, but sudden beacons, flashing their existence into the cosmos. The Ophiuchus cluster, with its gigantic cavity and ancient violence, may well be a region of such extreme conditions. Though no FRBs have yet been directly linked to it, we know that its environment is rich in magnetic turbulence, ionized gas, and relativistic jet sol ingredients in the alchemy of radio bursts. Perhaps what we call FRBs are glimpses, not of final death, but of transformations within these monstrous systems. Flickers from the edge of the abyss. Some bursts repeat, their signals returning with eerie regularity. Others are singular, one-time events. The repeating ones may suggest a stable mechanism rotating magnetar, perhaps, or a disk of matter periodically disturbed. But the non-repeaters carry a more haunting message. They are cosmic cries we hear only once, echoes of moments that will never happen again. What if the Ophiuchus outburst sent such a signal? Not a visible one, not a jet or a wave, but a singular flash in radio, a note in the cosmic symphony missed by our instruments or mistaken for noise. A message, not crafted with intention, but written by the conditions of extreme reality. Radio telescopes like CHIME, FAST, and Meerkat are now listening day and night, mapping the sky not in images, but in transient signals. With each burst, a puzzle piece falls into place. And while most come from galaxies far beyond Ophiuchus, their study informs us about the environments in which they are born. Each FRB is like a flare, sent up from a distant battlefield where gravity and magnetism clash in scales we cannot recreate. To connect FRBs with black holes is to imagine a new kind of language, not continuous, not predictable, but sudden and full of meaning, a staccato rhythm of the void. It would mean that even in the seeming finality of a black hole, there are still ways for the universe to speak. If we could learn this language, what might we understand? Could FRBs carry clues about space-time distortions? About the properties of matter at the brink of collapse? Or even about the nature of dark energy? Could they be the footnotes to the grand narrative of outbursts like Ophiuchustini, explosive annotations left for those listening in the right frequency? There is a growing idea that the future of astronomy lies not in grand observatories gazing in one direction, but in networks of sensors watching everything, everywhere, all at once. The sky is alive with events, most too brief or faint for traditional observation. But in the flickers and flares, in the momentary radio pulses and vanishing X-ray jets, the true character of the universe reveals itself. Black holes, once thought to be purely silent, may turn out to be deeply expressive not in voice, but in impulse, in occasional flashes, in distortions, in absences that sing, and perhaps, in the story of cosmic monsters, FRBs are the whispers of their thoughts, the nervous ticks of systems under strain, the brief confessions of matter before its final transformation. We are still decoding these signals, still arguing about their origin, still learning what it means to listen to the universe not as a steady hum, but as a burst of messages, each demanding interpretation. And perhaps that is the greatest lesson of all, that the cosmos does not speak in our time. It does not follow our cadence. Its language is more like poetry, dense, sudden, elliptical, full of ellipses and eruptions. And every FRB is a verse in that strange cosmic poem. What if the black hole in Ophiuchus has already spoken in this language, and we simply weren't listening? What else have we missed, while searching for something more orderly, more expected? The monsters may not be silent, they may simply speak in flashes. And we are only beginning to understand what they are trying to say. In the mind of humanity, monsters often dwell in caves, in shadowed forests, in the cold depths of the ocean. They are creatures of myth and warning, embodiments of danger and awe. And yet, in our modern cosmos, the monsters have changed their address. They now reside at the hearts of galaxies, cloaked in gravity, invisible to the eye. But just like their mythic ancestors, they leave signs, and some of those signs are etched into the very structure of the Milky Way. At the center of our own galaxy lies Sagittarius A, a supermassive black hole with a mass 4 million times that of our Sun. It is not the largest, nor the most active, but it is Ursa patient behemoth hidden behind veils of dust and gas, located 26.0 light-years away in the direction of the Sagittarius constellation. For decades, it was suspected to exist, but only in the last few years did we finally see its shadow thanks to the Event Horizon Telescope, a planet-sized array of synchronized observatories that captured the silhouette of its accretion disk, bending light into a glowing ring. That image was more than a photograph. It was a map of a boundary, the last surface from which light can escape, and it confirmed that at the heart of our spiral galaxy lies a gravitational anchor, a structure so dense, so absolute, that it defines the orbits of stars, the flows of matter, even the possible future of the Milky Way. Around Sagittarius A, stars whip around at incredible speeds. One in particular, named Stu, completes an orbit every 16 years, moving at several percent the speed of light during its closest approach. These orbits are more than astronomical curiosities. They are tests of Einstein's theory of general relativity, and they confirm, again and again, that the predictions of warped spacetime and gravitational time dilation are real. But they also raise questions. If such a massive object sits at the center of our galaxy, what is its history? How did it form? And has it, like the monster in Ophiuchus, ever erupted? Some believe that Sagittarius AY was once far more active, that in its youth it may have blazed like a quasar, devouring gas at ferocious rates, releasing jets and winds that sculpted the galactic core. There is evidence of past activity in the Fermi bubbles, enormous lobes of high-energy gamma radiation stretching above and below the galactic plane. These could be the fossil remains of an ancient outburst, a quieter cousin of the Ophiuchus event. If true, then even our own galactic monster once roared, long before Earth cooled, long before the first life stirred in shallow seas. It is now in a resting phase, but that sleep is not guaranteed to last forever. Black holes can awaken. Should Sagittarius A become active again, it would not pose a direct threat to Earth. We are far enough away, but the transformation of our galaxy's center would alter the radiation environment, send waves of energy across interstellar space, and rewrite the structure of gas clouds and star-forming regions. It would be, for our descendants, a visible reminder that the heavens are not fixed, and that even ancient monsters can rise anew. And yet, there is something intimate about knowing this monster. Unlike the distant behemoths in Ophiuchus or Perseus, this one belongs to us. It is part of our home. It holds the Milky Way together, providing the centrifugal balance that keeps the spiral arms in place. Without it, the galaxy would not be what it is. There is a paradox in that a monstrous thing being also a stabilizing force, a destroyer that enables harmony. But this is the pattern we keep finding. In cosmic structures, as in life, the agents of death often carry within them the seeds of life. Black holes shape their environments. They regulate growth. They redistribute energy. In this, they resemble ecosystems more than explosions. They are engines of transformation. And Sagittarius A, though quiet now, has played its role in sculpting the place we call home. It is a quiet kind of power, not loud or immediate, but patient, gravitational, a power that waits. And perhaps this is the truest mark of a cosmic monster. Not its appetite, not its rage, but its endurance, its ability to persist, to define, to shape without being seen. When we look into the center of our galaxy, we are not peering into chaos, but into history, into memory, into the deep well from which the structure of the Milky Way emerged. And we are seeing not just where we are, but what we orbit, what holds us. And that changes everything. We are not adrift, we are bound. Not by chains, but by gravity, by structure, by a center we cannot touch, but that shapes our path all the same. So the next time you look up at the Milky Way's soft band, remember what lies behind it. Not just stars, not just dust, but a shadow so powerful, it holds the galaxy in its grasp. A monster, yes, but also, perhaps, a keeper. And that, too, is a kind of story worth telling. If we could zoom out far enough, drifting beyond our galaxy, past the local group, beyond the shimmering edge of superclusters, the structure of the universe would begin to reveal its deeper geometry. Not in lines or walls, but in a latticea, great cosmic web of filaments and voids, clusters and knots, spanning the observable cosmos like the nervous system of some sleeping titan. And threaded through this web, like silent neurons in a brain of unimaginable scale, are the black holes. They do not shine, but they hold everything together. The cosmic web is not just a poetic metaphor. It is a scientific reality, mapped through the distribution of galaxies and gas, revealed through gravitational lensing, and confirmed by simulations run on the world's most powerful supercomputers. Where the filaments intersect, matter is densest, galaxies cluster, and supermassive black holes reside. In the great voids between, gravity still pulls, though gently, slowly shaping the cold winds of intergalactic space. The most advanced simulations like Illustris and Eagle have shown that black holes are not merely passive endpoints, but active participants in cosmic evolution. Their feedback, the energy and particles they eject through jets, winds, and outburst shelps regulate the growth of galaxies. In regions of high density, this feedback prevents the overcooling of gas, suppressing runaway star formation. It is a paradox. The most destructive forces in the universe are the very ones that keep it from unraveling. What emerges is a vision of balance. Galaxies are not isolated islands, but cells in a larger organism. Their black holes are not dead centers, but pulsing hearts. And when one erupts, like the beast in Ophiuchus, its influence stretches far beyond its host, stirring the cosmic web-like wind through a spider's threads. Some cosmologists have begun to wonder whether this web has properties beyond mere structure. Could it transmit information? Could the arrangement of matter, the flow of energy, the ripples of gravitational waves be part of an unconscious processive form of emergent intelligence on scales we cannot yet comprehend? It is not science fiction. It is a question rooted in the mathematics of complexity. In highly connected systems, behavior can emerge that is not apparent from the individual parts. Neural networks are one example. Could the universe, with its trillions of galaxies, its dark matter filaments, and its black hole nodes, exhibit a similar phenomenon? If so, the monsters are not just points of collapse. They are the connectors. The nodes where information flows inward, processed by gravity and extreme physics, and released again in energy, in radiation, in structure. Each outburst, each cavity like Ophiuchus, becomes not just a wound, but a signal, a spark in the neural map of the cosmos. This idea remains speculative, but even without invoking intelligence, the role of black holes in shaping the universe is undeniable. They create balance, they enforce rhythm, they give structure to chaos. And that structure reaches us. Our own galaxy is connected to the larger web. The Milky Way is part of the Laniakea supercluster, a vast region of gravitational flow that encompasses hundreds of thousands of galaxies. We are drawn, along with our neighbors, toward a region called the Great Attractor, a gravitational anomaly whose cause remains partially hidden. Some suspect it is the product of dense clusters, massive voids, and perhaps ancient black hole activity. To move through the universe, then, is to follow currents shaped by monsters, to drift along rivers carved by gravity and ancient light. And in this dance, we are not observers, we are participants. Our planet, our solar system, our very atoms are being pulled, shaped, carried along by the breath of structures far beyond our scale. This changes how we see our place. We are not at the center, nor are we on the edge. We are woven into a fabric so vast it seems still, but is always moving. And the black holes, silent though they are, may be the conductors of this motion. They act across epochs. Their influence unfolds in billion-year symphonies, and yet in the cavities they leave, the jets they fire, the filaments they help form, they speak a kind of language, not of words, but of form. To study the universe is to learn this language. Not to dominate it, not to solve it, but to listen. And what we hear is this: the cosmos is not made of chaos alone. It is not the result of blind accidents, of random eruptions. It is a place where violence gives rise to beauty, where silence gives rise to structure, where the most fearsome entities serve the most delicate purposes. The monsters are real, but they are not alone. They are part of something larger, something older, something that continues to unfold with every photon, every tremor, every cavity in the gas. And perhaps, when we finally learn to see the full web, when our instruments grow sensitive enough to map not just matter, but influence, we will see them for what they are. Not destroyers, but architects. And in their dark designs, we may find the outlines of something even more mysterious. Purpose. In the world of science, there are discoveries that illuminate the path forward, and then there are those that cast longer, stranger shadows. In 2019, astronomers analyzing data from the X-ray satellite MAXI detected a sudden, massive flare of energy erupting from the heart of the Milky Way. The source? Sagittarius A, the supermassive black hole we call our own. For a few hours, it glowed 75 times brighter than normal, a brief awakening that left scientists puzzled and curious. No one knows exactly what caused it. Perhaps a rogue gas cloud wandered too close. Perhaps a magnetic reconnection event, akin to solar flares, released a sudden burst of energy. Whatever the cause, the event was a reminder that even sleeping giants can stir, and when they do, the galaxy notices. The timing of such outbursts raises deeper questions. Are they truly random? Or are we seeing the surface of a deeper cycle, a rhythm of galactic breathing too slow for human history to record? If so, what governs these rhythms? Could they be influenced by interactions between dark matter and normal matter, by the orbits of stars and dust, or by the complex interplay of magnetic fields that thread the galactic core? In seeking answers, scientists are beginning to draw connections between black hole activity and phenomena that seem far removed. One such link may lie in the mysterious alignment of galaxies over billions of light years. Some observations suggest that the spin axes of certain galaxies are correlated across immense distances, a pattern that defies our expectations of randomness. Could black holes be part of this alignment? If jets from active galactic nuclei influence the angular momentum of surrounding material, and if those black holes formed in similar early universe environments, then their alignments may have a common origin. Like iron filings drawn along magnetic lines, the galaxies may be echoing ancient imprints left by conditions present in the primordial universe. This possibility has profound implications. It would mean that the monstrous outbursts we study today, like Ophiuchus or Sagittarius AY, are not isolated events, but expressions of an underlying geometry. That when a black hole erupts, it is not merely reacting, but participating in a larger pattern. It is as if the universe has a memory, not in the biological sense, but in structure, in the way matter arranges itself, in the way energy flows, in the echo of alignments that stretch across space like chords in a grand symphony. And in this symphony, black holes play the low, resonant notes, subtle, powerful, impossible to ignore. They do not dominate the melody, but they anchor it. They give the cosmos weight. If we are to understand this song, we must learn to listen not just to what changes quickly, but to what endures, to the slow rotations of galaxies, to the rare awakenings of black holes, to the faint alignments that hint at something larger than chance. This is not merely an exercise in astronomy. It is an expansion of awareness, a reminder that our sense of time is narrow, that our grasp of cause and effect may miss patterns that unfold over eons. Perhaps we are just beginning to see the outlines of these patterns. Perhaps the flare from Sagittarius A was not an anomaly, but a phrase in a longer sentence we have only just begun to read. And if that is true, then the monsters of the cosmos are not chaotic. They are composers. Their eruptions are punctuation. Their alignments are grammar. And the universe, in all its darkness and silence, is telling a story we are just now learning to hear. A story not of endings, but of continuity. Of forces that rise and fall, but never vanish. Of structures that span galaxies and ages, written not in ink or stone, but in jets of plasma and filaments of gas. A story where the black holes are not voids, but verbs. And we, brief though our presence may be, are part of the audience. We stand on a quiet planet, in a quiet moment, and we listen to the deep sky, to the monster that stirred, to the patterns that remain, to the vast and patient voice of time. Among the countless wonders of the universe, there is perhaps none more humbling than the realization that the laws which govern the cosmos are so consistent, so stable, that they allow for memory across billions of years. A photon released from a star 10 billion years ago still travels in a straight line. A gravitational wave from a distant merger still carries the curvature of its source. And in this framework of dependable lawfulness, black holes operate not as violations, but as the most precise expressions of these rules. And yet, within their boundaries, our understanding begins to unravel. The event horizon of a black hole is more than a surface. It is a threshold where time and space exchange roles, where cause and effect bend, where classical physics yields to quantum mysteries. To enter a black hole is to pass beyond our current capacity to model reality. It is the most extreme laboratory of natura, place where general relativity and quantum mechanics collide, and where neither offers the full answer. This has led scientists into a new realm of thought, one that connects black holes to questions of information, entropy, and the very architecture of reality. In the 1970s, Stephen Hawking made a revolutionary discovery. Black holes are not entirely black. Through a quantum process, now known as Hawking radiation, they emit particles over time. This implies that black holes can evaporate, losing mass slowly until they disappear. But if this is true, what happens to the information they contain? This question gave rise to the black hole information paradoxon, of the most profound puzzles in modern physics. If information is truly lost in a black hole, then quantum mechanics, which insists that information is preserved, must be incomplete. But if information is preserved, how does it escape a region from which nothing, not even light, can emerge? In the decades since, many have tried to answer this question. Some suggest that information is encoded in the event horizon itself, stored like a hologram. Others propose that it leaks out in subtle correlations hidden in Hawking radiation. And still others believe that black holes are only apparent horizons, that there is no real loss, only a transformation beyond our current comprehension. These ideas converge around a deeper insight, that the universe may be, at its core, informational. That matter, energy, space, and even time are emergent properties, rising from the deeper foundation of quantum bits, entanglement, and computational geometry. In this model, black holes are not just objects, but processing centers, places where the structure of reality is reorganized. The implications are immense. It means that the monsters we observe, those like the black hole in Ophiuchus, those like Sagittarius A, are not just consuming matter, they are computing, transforming, refining the code of the universe in ways we are only beginning to suspect. If this is true, then the great outburst in Ophiuchus is not merely an act of destruction, it is an output, a signal, a release not only of energy, but of processed structure, an exhalation from a cosmic engine. This perspective invites us to rethink black holes not as voids, but as transitions, not as endings, but as gates. And it aligns with ancient intuition. For thousands of years, human cultures have described sacred thresholds, places where the known meets the unknown, where transformation occurs, where reality thins. The gates of the underworld, the mouths of caves, the temples at the edge of the desert, these are metaphors for the same tension we now see in physics, the boundary between what we can measure and what we cannot. The black hole is the cosmic version of that gate. It is the veil that dares us to peer beyond. And perhaps the story it tells is not one of annihilation, but of renewal. In that light, the universe becomes a dialogue between what is visible and what is hidden, between stars and shadows, between radiation and curvature, between what enters the monster and what eventually emerges. If information is never truly lost, then the universe remembers everything, and if it remembers, then each outburst, each flare, each cavity is a moment in a vast and intricate memory. The Ophiuchus event may be one sentence in that story, a punctuation mark in the long grammar of transformation. We stand, as ever, on the shore of this vast sea, gazing into its depths with instruments and equations, with wonder and curiosity, and in our reflections, the monsters grow clearer, not as threats, but as invitations, to think differently, to listen more carefully, to imagine a universe where darkness does not end the story, but begins a new chapter, and where the monsters are not what we feared, but what we are destined to understand. Far out on the edge of the observable universe, where galaxies become mere whispers in the cosmic static, we confront a horizon not of space, but of time. The light from these distant objects left them when the universe was still young, and what we see now is not their present, but their long-faded past. In this light, we search not for new places, but for echoes, for records of the universe becoming what it is. And in these records, black holes speak as well. In the earliest epochs, less than 1 billion years after the Big Bang, we find quasars' brilliant beacons, powered by supermassive black holes, devouring matter at phenomenal rates. These objects shine across the darkness of cosmic dawn, their light racing toward us across 13 billion years of expansion. And their very existence poses a challenge. How did black holes grow so large, so fast? To form a billion solar mass black hole in such a short time requires either an extraordinarily efficient feeding process or a massive seed, perhaps, a direct collapse black hole formed not from a star, but from the collapse of a primordial gas cloud. If such seeds existed, they would have rewritten the early structure of the universe, accelerating the emergence of galaxies, altering the path of cosmic evolution. Some researchers propose that these early monsters grew by mergers, black holes combining again and again, forming larger and more chaotic systems. In these collisions, gravitational waves would be released, shaping the very curvature of space-time and sending ripples through the early universe. If we could detect these ancient waves, perhaps with the future space-based observatories like LISA, we might one day listen directly to the birth cries of the first galactic hearts. But for now, we see only the light, and that light is powerful. The energy released by these early quasars is enough to ionize vast regions of intergalactic gas, ending the cosmic dark ages and initiating the reionization of the universe. In this sense, black holes were not only passive consumers, but catalysts of transformation. They brought light to a darkened sky. They reshaped the cosmic landscape. And if that is true, then our vision of the early universe must change. It is not a silent cradle. It is a battlefield of emergence. A stage where monsters grow fast and bright, changing the rules before they can be written. The largest known quasar, TON 618, harbors a black hole with a mass of over 66 billion suns. Its light took 10 billion years to reach us. It is an ancient lighthouse, still visible across the vast sea of time, and it is not alone. We have cataloged thousands of quasars, each powered by a black hole more massive than any star, some older than expected, some stranger than predicted. They are not anomalies, they are signals. Signals that black holes do not wait. They grow, they ignite, they shape, even in the beginning. And this discovery humbles us, because it reminds us that the conditions we see now, the calm of our galactic neighborhood, the predictability of stellar evolution, are not the whole story. There was a time when the universe was ruled by the chaotic growth of these titanic engines. A time when the monsters sang their brightest songs, when the sky was more active than quiet. It is possible that some of the oldest black holes still exist, cloaked in darkness, their light long extinguished, their hunger satisfied. They may wander the void between galaxies, relics of a more turbulent age. They may anchor the centers of dead galaxies, invisible but still present. Their role is no less important for being unseen. If these black holes still exist, then they are the elders of the universe, the keepers of its earliest memories. They were here before the stars we see, before the dust of our planets formed, before the cycles of chemistry that led to life began. And so, as we stare into the ancient sky, we are not merely looking back. We are reaching toward them, toward our origins, toward the scaffolding that made all this possible. The first black holes may have taught the universe how to organize itself. They may have been the first architects of pattern. The Ophiuchus outburst, for all its power, is a recent whisper compared to the roars of the first quasars. But it connects to them. It belongs to the same lineage. A family of events that spans time, that stitches together the fabric of existence with bursts of energy and waves of gravity. We cannot yet know everything they did, but we know they were there, and we are their descendants, born of stars, guided by gravity, raised in a universe where monsters made the first marks. Perhaps the deepest truth of all is this, that the monsters came first, and from their shadows, light emerged. There is a concept in theoretical physics known as the cosmic censorship hypothesis. It suggests that nature hides its singularities, the infinitely dense points where the laws of physics break down behind event horizons. In other words, the universe keeps its secrets cloaked. The monsters are veiled. We can sense their presence, feel their pull, observe their influence, but we are never allowed to look directly into the heart of their mystery. But what if that veil slips? What if there are cracks in the fabric where something more is visible, if only for a moment? In 2019, astronomers witnessed a strange phenomenon, a black hole devouring a star in a distant galaxy, a process known as a tidal disruption event. The flare of light released was immense, but then, unexpectedly, it dimmed. Then it flared again, brighter than before. Something had caused the stream of material to flicker, to pulse with an unnatural rhythm. Some suggested magnetic reconnections or interactions with a secondary object. Others began to whisper about something stranger, the possibility of a naked singularity. A naked singularity would be a place where the veil lifts, where the laws of space and time collapse, not hidden behind an event horizon, but exposed to the universe. If they exist, they would be windows into a regime of physics we do not yet understand. They would be glimpses into the raw engine of reality. So far, no naked singularity has been confirmed. The cosmic censorship hypothesis still holds, but the very act of imagining such a thing reminds us of the limits of our knowledge, of how thin the curtain may be. Some string theorists propose that under certain conditions, higher dimensional phenomena could pierce into our reality, creating transient anomalies that mimic or disrupt black holes. These would not be monsters, but phantom shadows from another realm, briefly touching our own. In such moments, our instruments might detect impossible bursts, inexplicable fluctuations, or patterns that defy known forces. What we consider a black hole could sometimes be more than it seems. And the Ophiuchus outburst? Could it too be more than just a record-breaking release of energy? Could it be the trace of something older? Strangira veil momentarily lifted, a deeper mechanism laid bare. When the cavity was first discovered, it was larger than expected. The energy required to produce it was beyond any previously recorded event. The structure was unusually symmetrical. These are anomalies, not in the sense of impossibilities, but of open questions, clues. Perhaps there are rules we have yet to write. Perhaps the black holes are not just devourers, but doors. Not just centers of gravity, but thresholds into a broader landscape. If so, what lies on the other side? We may never know. But the pursuit itself matters, because in chasing these mysteries, we reshape our own understanding of reality. We create new mathematics. We build finer instruments. We expand our language. The monsters challenge us, and in doing so, they teach us. This is their gift, and their paradox. They are defined by what we cannot see, by the very limits of measurement, and yet they drive our knowledge forward. Each question they raise is a step toward a deeper clarity. There is beauty in that, in the idea that the dark can be instructive, that the unknown is not just a threat but a horizon, a promise of further revelation. The cosmic censorship hypothesis tells us that the universe protects us from its wildest truths, but maybe, just maybe, it also invites us to approach them, little by little, to earn our glimpses, to become worthy of understanding. In this light, every black hole becomes a teacher, not because it reveals, but because it withholds. And in the tension between what is known and what remains hidden, we find the space in which wonder grows. We look through our telescopes, we gather photons from across time, we build models and simulate epochs, and through all of it, the monsters remain just out of reach, not as a warning, but as an invitation to seek, to imagine, to listen, not for answers, but for better questions. And in that pursuit, the cosmos becomes not just a place, but a conversation. There is a moment, just before dawn, when the sky holds its breath, when darkness has not yet surrendered, but light is beginning to press its fingers into the edges of the world. It is a moment of in-between, a threshold, and it is in such thresholds that the story of black holes finds its deepest meaning, because they too are in between visibility and silence, between destruction and creation, between the laws we know and those we have yet to discover. The Ophiuchus outburst, the brightest and most powerful ever recorded, was not just a cosmic eruption. It was a punctuation mark in a language we are still learning to read. A message written not in ink, but in absence, in cavities of gas and echoes of force. It told us that monsters exist, that they can wake, that they can reshape the universe around them without sound, without warning, without intent. And yet, in their fury, they bring balance. This is the paradox we must carry forward, that what we fear in the cosmos may be the very thing that allows beauty to exist, that the void does not simply consume, but transforms, that the gravitational scream of a black hole is also a kind of harmony, deep, slow, and utterly alien. We once imagined monsters as things with claws and teeth, as dangers lurking in the night. But now, we see that the true monsters are not creatures of malice, but of mass. Not beasts, but boundary conditions. And they are not rare, they are everywhere. In the center of galaxies, in the silence between stars, in the equations that hold our models together, and perhaps in the core of our own understanding. Because to study black holes is not only to look outward, it is to look inward, into the way we frame questions, into the assumptions we bring to the edge of the unknown. The horizon of a black hole is also the horizon of our knowledge. And every time we draw closer, the universe responds. With another flare, another ripple, another silence that speaks volumes. We are not done exploring. The more we build, the more we listen, the more we find. From gravitational wave detectors to space-based observatories, from radio telescopes to quantum theories, we are mapping the dark with tools of light. And through all of it, the monsters wait, not as enemies, but as guardians of mystery, of memory, of the very structure of the cosmos. They do not ask for reverence, they do not require mythology, but perhaps they deserve something like respect. Because in their presence, we become more than we were. We become seekers, translators, storytellers. And so, as we close this exploration, we must remember The most powerful cosmic monster ever recorded was not just an event, it was a mirror, a glimpse into the architecture of everything. A reminder that the universe is not silent but speaking, that its monsters are not endings but beginnings. And if all this is true, then we are not lost in the dark. We are listening, and the sky, in its vast and quiet way, is listening back.